आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello students, the question here is, there is a first part, A part of a question is, differentiate between three segments of a transistor on the basis of their size and level of doping. Part B is, how is a transistor behaves to be in active state? Part C, with the help of an SSC circuit diagram, describe briefly how NPN transistor in CE configuration amplifies a small sinusoidal input voltage. Write the expression for the AC current gain. So here there is a three part of the question. First we discuss about the first part, that the three segments of a transistor. Here the first segment of transistor is, that is emitter, and it is simply denoted by E in the figure, and it is heavily doped. And is the left hand side. It is the left hand side thick layer of the transistor. And the second part of the transistor is, that is base. It is a central thin layer of transistor, and it is lightly doped. Remember, the emitter is heavily doped and the base is lightly doped. I will just change the spelling. There is lightly doped, L-I-G-H-T. Lightly doped. It is about the base. And the third part of the transistor is, that is collector. That we call it as a collector. It is on the right hand side thick layer of the transistor, which is moderately doped. I will repeat again. Emitter is heavily doped, base is lightly doped, and the collector is moderately doped. So it's the first part of the answer of the first part. And second part, that how it can be work in active state. Okay. Here there is the answer of part B. How it can be worked in active state. So there are two basic conditions for the transistor to be in active state. Here the condition first, the input circuit must be, or we can say should be, forward bias. By, remember one thing, by using a low voltage battery. And second condition, that output circuit must be reverse bias. By high voltage battery. So now come to the part C, where what we have to discuss, simply we have to discuss the NPN transistor as an amplifier here. Simply in short form, amplifier, and just give an expression for the AC current gain. So it is the basic figure which is clear to you. I will explain one time here, that this is a transistor, NPN transistor. This is NPN transistor as an amplifier, where the emitter base junction where the meter base junction input circuit is forward bias and output circuit is reverse bias, With high voltage battery, it is a low voltage battery. I can explain its working with, so that's the figure, and the answer is very much clear to you students. So yes, I will discuss the part C here. That we already tell input circuit is forward biased by low battery. So what will happen if the battery will be low? Then we can say that the resistance of input, the resistance of input circuit is small. Then output circuit is reverse biased. I already tell that high voltage battery. So ultimately, resistance of output circuit will be large. Resistance of output circuit will be quite large. Now, the operating point is always fixed in the middle of the active region. Operating point is fixed in the middle of the active region. Active means that where it is the input is forward and output is reverse biased. This is the active state of the transistor. Now, the output is taken between the collector and the ground. Here, this output is taken between the collector and there is a earthing of a meter junction here. Ground. So what is the formula of output here? By using the Kirchhoff's law to the loop. Kirchhoff's law to the loop, the output should be equal to collector battery, collector emitter voltage plus IC RC. These are the resistances, collector resistance here. This can be shown here, that is RC. Now, what we have to do here, student? Now, we can say that input signal is fed into the emitter based circuit, which will change the emitter voltage and hence the emitter current, which will change the emitter voltage, thereby also change the emitter current, and if the emitter current changes, so which can also change the collector current. Collector current denoted by IC, emitter IE. So due to this, the collector voltage will vary as per this relation. Collector voltage will vary as per this relation. For that, this relation should be is the equation 1. Then what will happen here? The variation which we got, it should be the variation which we got should be the amplified output. So input is less, while we get the more output, which we can amplify it. Amount increases. We got amplified output in a signified manner. So then we can also write it about the input there, VBB battery. To be also expression for a current again here is equal to VBE plus IRRB. Now we know that input current, input voltage not equal to 0. So we can say that VBB plus VI should be equal to VBE VBE plus base current to base resistance plus change in base current into RB plus input RL here. So now, how we can write that expression clear from the fact that we know that RL should be equal to input resistance, RL should be equal to change in base emitter voltage upon change in base current here. So VI should be equal to delta IB plus into yes, I will erase it down. Simply write here into RB plus input resistance here. So it should be equal to R, simply written as also equal to R delta IB. So what is beta AC current again factor should be equal to delta AC upon delta IB. So it is the required expression for current gain. So I hope all the part is now clear to you students. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।